Hello guys, welcome to our class for today. This is Nobleman Science Tutors Online and I remain Otto Michael. Today we are discussing mirror formula. We've started discussing curved mirrors and we've solved some problems on curved mirrors already. So in our class for today we'll be discussing the mirror formula and then we'll see how we can apply it to solve some problems to find the focal length of a lens or image distance, object distance, image height, object height, and what have you. So today we are going to discuss the mirror formula and then also use it to solve some problems. Is that okay? So there will be less discussion. We are going to solve more problems today. So if you have your writing materials ready, please I want you to just get yourself ready so that we can go straight to our class for today. Right, so please, if you have not subscribed to our channel, please subscribe to the channel, give us a thumbs up and give us a like so that whenever we upload a new video, YouTube can notify you. Right, you can also invite your friends and so that they can come and enjoy this physics lecture that's on YouTube. Reach us through the WhatsApp number that's showing on your screen. Okay, so that if you have any challenge, we can discuss it together and see how we can help you out. Okay, so today, as I said, for this particular class, we are looking at the mirror formula. So if you are there, please let us go straight to our class for today. So basically, this is the mirror formula. If V represents image distance and U represent object distance and F represent the focal length of the mirror, then the image distance, the object distance, and the focal length, they are related by this equation. This equation is the mirror formula. Or if you find a simple interest and you want to find the focal length, you can evaluate this to get this. Okay, you can evaluate this particular equation in order for you to get this. So simply just for you to find the LCM, then do your addition and all that. So that one basically is simple for you to do. So just for you to find the LCM of 1 over V plus 1 over U. You know that the LCM of 1 over V and 1 over U is equals to VU. So if this goes into here, you have V, and this comes into this, you have U. Okay, so F will be equals to the inverse of that, which is VU all over V plus U. Okay, so and that's just it. Okay, so and remember that we said that the radius of curvature is equals to 2f. So which means that f is equals to radius of curvature all over 2. Remember this, because this is what we're going to be using to solve problems. Then also remember that this is the formula for magnification. Treated this in our previous videos, right? Magnification is equals to image height over object height is equals to image distance over object distance, or image size all over object size, as the case may be, depending on the equation that you are given. All right. Now graphically represented, if you plot the graph of 1 over V against 1 over U, if you plot the graph of 1 over V against 1 over U, you are going to have your intercept on both sides to be equals to 1 over F. You're going to have your intercept at both sides to be equals to 1 over F. So this can come as a wire question, right? Okay, so you know that when you plot the graph of 1 over v against 1 over u, the intercept of the graph at both sides will be equals to 1 over f. Please take note of that. Now, if you multiply this mirror formula by v, you are going to have 1 plus v over u is equals to v over f. Okay, so if I do that multiplication on this, if you multiply this equation by v, multiply it by v, okay, you will have v, you have v over f equals to v over v plus v over u. Remember, this is what I'm multiplying the v by. Okay, I'm multiplying this by v. This particular equation now is what I'm multiplying this times v to give me that. Okay, so I hope you are following that. So now if you go further, you have that v over f is equals to 1 plus v over u. Now remember that v over u from our previous equation is equals to what? Is equals to v over u. Remember that v over u is equals to what? Magnification. So if you substitute for v over u, if you substitute m for v over u in this particular one, we are going to have that v over f equals to 1 plus m. So if you make m the subject of the formula, you have that m is equals to v over f minus 1. So this is another formula for finding the magnification of a lens, magnification of a mirror, of a curved mirror. We'll also get to this equation when we'll talk about lenses too in our further video that we're going to shoot. Okay, so if you plot the graph of magnification against if you plot the graph of magnification against v, you are going to have your intercept to be equals to minus 1. Okay, you have your intercept equals to minus 1 on the negative m axis. Alright, so this is how the equations are gotten. So shortly we are going to see how we can apply all these equations. So you just need to take note of these equations, and then as a good physics student you should be able to know how to maneuver and then derive some of these equations. Alright, so let's go and teach some problems on this particular mirror formula. So before we start to treat some problems on mirror formula, there is a convention that is normally used in solving problems when you are talking about the mirror formula, and this convention helps to distinguish, okay, the type of image that is formed and then the position of the image. Okay, so the two sign convention that are used are the real is positive sign convention and then new Cartesian convention. So but in most cases, once you understand how to apply these two conventions, when you are solving any problem, you can easily deduce the type of image that you will get as you are solving the problem. That is once you understand these two mode of finding using the mirror formula. Okay, so note, this is what I want you to take note of, that for concave mirror, the image distance is positive except when the object is between the focal point and the pole, or when the position of the object is less than the focal length. That is only when you have that's only when you will have a negative image. Okay, so if you follow the conventions that for real is positive convention, distances measured for real objects and images position are positive. That is what this statement also says. Also, distance measured for visual objects and images are negative. So that is exactly what I said here. For visual images and objects, their distance and the distance measured are negative. The focal length of a concave mirror is positive, while that of a convex mirror is negative. So that when you are solving, once you see the question and the question is saying concave mirror, you should know that the focal length is positive. If it is convex mirror, the focal length is negative. So in most cases, it is really is positive that we use to solve problems or using the mirror formula. But if you also understand the new Cartesian convention, you can also use it. The two will give you the same answer on the long run. For the new Cartesian convention, distances measured for opposite the incident light are negative. Then distance measured in the same direction as incident rays are positive. The focal length for new Cartesian convention, the focal length is negative, while for convex mirror is positive. So these are some of the different, but for simplicity and ease of understanding, it is good you understand one of the convention and use them very well. So I will prefer that you get yourself acquainted with real is positive convention, except the question says use new Cartesian convention. Be conversant with this one. For this particular convention, all distances measured between the object and the image, they are positive, except when the object is between the focal point and the pole. Then the focal length of the concave mirror is positive, while that of the convex mirror is negative. For real is positive. And remember that for all convex mirror, their images are visual. I think we have discussed the location of images in convex mirror, so you can review that video and get a clearer understanding. If you can understand those diagrams that I drew on location of images when you are solving problems, your mind should reflect back to those drawings so that you can know where the image is being formed on the concave mirror. Okay, so having said this, I will go now so that I can apply what I've told you now, because all I've said now is like discussion, but when I start to apply it to solving problems, it will become clearer and then you get a better understanding. All right, so let's go straight now and solve some problems. Okay, so this is question number 1. For this, we are given for this particular, it said an object 20 centimeter high is placed a distance of 20 centimeter from a concave mirror of radius of curvature 30 centimeters. Calculate the position, the size, and the nature of the image. Calculate the position, size, and nature of the image, which means that you are going to calculate the image distance, you are going to calculate the image size, then the nature of the image. Okay, so for this particular question, you are giving for in this particular case, I'm going to use small h to represent object height and big H or capital H to represent image height. So please, you pardon me so that we can use that. Okay, so h, which is going to be image height, is going to us to be 20 centimeters. Going to us to be 20 centimeters. Then image distance u is given to us to be 20 centimeters again. As image distance is given to us with 20 centimeters. Radius of curvature is given to us to be 30 centimeters. Now we have said that focal length is equals to what? Arrow over 2. So which means the focal length is 30 over 2. Okay, so that gives us 15 centimeter. So the focal length is equals to 15 centimeters. Alright, so this is the focal length. Now, since we know the focal length, we know the object distance, we can actually look for the image distance. So from the mirror formula is 1 over f equals to 1 over v plus 1 over u. So what are we looking for? We are looking for v, which is the image distance. So we can make that the subject of the formula. So we say that 1 over v is equals to 1 over f minus 1 over u. Remember I said that it is good you master one of the conventions. So for this particular question, I'm using real is positive. So for real is positive, the focal length of a concave mirror is positive. Is that okay? So f is positive for real is positive. That's what I'm using. So substituting to this equation, you have 1 all over 15 minus image distance, which is 1 over 20. Okay, so the LCM of 15 and 20 is 60. Okay, 15 go into 60 is equals to 4, and 20 into 60 is 3. So by the time you work this out, you're going to have 1 over 60. So if you invert this to find v will now be equals to what? 60 centimeters. So that is the position of the image formed. Now what about the size of the image, which is the magnification? Magnification is equals to v all over u. Remember, so just put them, that is 60 all over 20. So magnification will be equals to what? 3. So since the image distance is positive, the nature of the image is that the image is a real image. I told you before that real images are formed by the actual intersection of the rays of light, while virtual images are formed by visual intersection or apparent intersection of the rays of light. So this is how to go about this type of problems. We have been able to find the image distance, the magnification, and then the nature of the image to be real. Alright? This is another question. See that an object is placed 10 cm in front of a concave mirror whose radius of curvature is 12 cm. Calculate the position, nature, and magnification of the image formed. I think this one is almost like the one we just did now. This one is almost like the one we did now, but in this case we are giving u to be equals to 10 centimeters. We are giving arrow to be equals to 12 centimeters. So from here we know that f is equals to arrow all over 2. Don't forget, so which is 12 all over 2. So which means the focal length equals to 6 centimeters. Okay, then after that we are looking for image distance, which we don't know. We're also looking for magnification, which we don't know. Okay, so from the mirror formula we had that 1 over f is equals to 1 over v plus 1 over u. So we are looking for v. So just like the way we did in the previous case, 1 over f minus 1 over u. So substitute this into this equation. You have 1 all over 6 minus 1 all over object distance is what? 10. So the LCM of 6 and 10 is 60. 6 going to 6 going to 60 is 10, and 10 divided 60 is 6. Okay, so that gives you 10 minus 6, 4 all over 60. So 1 over v is equals to 4 over 60. V is equals to 60 over 4 over 4. By the time you work that out, you have that V is equals to 15 centimeters. Is that clear? So V is equals to 15 centimeters. So the magnification of the image M is equals to V all over U. So that gives us 15 over what? 10. By the time you work this out, you're going to have 1.5. Also, the image of this one is also real. The image is real. Okay, so this is how to apply this formula to solve problems in using the mirror formula. They are not really that difficult. Is that okay? Just for you to understand how to apply them and use them to solve problems. That's all. This one, calculate the position of an object placed in front of a convex mirror having a focal length of 12 cm such that an image is formed 6 cm away from the mirror. Now, for real is positive sign convention, the focal length of a convex mirror is negative. So let's see how we're going to apply this. Okay, so we are giving the focal length of the mirror to be 12 centimeters. So as I said, the focal length here will be minus 12 centimeters because it's a convex mirror. Alright, so it will be minus 12 centimeters. Then we are giving the image distance V to be equal to 6 centimeters. The image of a convex mirror is a visual image, so it is also negative. So that will be minus 6 centimeters. Take note of this that I'm doing now. For a convex mirror, the image is visual, so the image is negative. The focal length is negative for a convex mirror. So here they said we should find the position of the object. This is what we are looking for. We are looking for the position of the object. Okay, so using the mirror formula, we'll say that 1 over F is equals to 1 over V plus 1 over U. Okay, so substituting into this equation, we want to substitute our information into the equation. We want to find U. So let's make U the subject of the formula, 1 over U. So 1 over U will be equals to 1 over F minus 1 over V. So if you substitute these values of F and V into this equation, taking cognizance of the signs that are on them, that F is negative and V is negative, we are going to have this as minus 1 over 12 minus bracket minus 1 over 6. Now we know that when you remove this bracket, minus minus will be equals to plus. So this will give us minus 1 over 12 plus 1 over 6. Is that okay? So now just find the LCM. So find the LCM of 12 and 6 is equals to 12. So that is 12. Where you have my 12 going to 12 is 1. So minus 1 plus 2. This gives you what? 1 over 12. So 1 over u is equals to 1 over 12. Okay, so this gives that u is equals to 12 centimeters. So your image is positive. You should go and check, your object distance is positive. You should go and check the diagram for the location of image for convex mirrors. You will find out that the object is always positive. It is the image that is negative. And that is what this particular equation or question has proven to us. Alright? That's what this question has proven to us. I hope this one is clear. You see the way I use a sign to solve this problem. So this is how you go about using this mirror formula to solve some problem for yourself. So this is your test page. You can solve more problems. These are the ones I could lay my hands on. Okay, so you check some past questions and you should be able to have more questions for you to solve in order for you to get a better understanding of the use of the mirror formula. Alright, so thank you guys. This way I'm going to stop this particular class. Thank you for your time. We appreciate you so much. But please, if you have not subscribed to our channel, please click on the subscribe bell, click on the notification bell so that when we upload a new video, YouTube will notify you. Okay, so thank you so much for your time. If you have any challenge or any problem in physics, please kindly reach us through the WhatsApp number showing on your screen so that we can be able to assist you and help you out, right? We want you to be a better you in physics. So this is your physics video tutorial and I remain Otobo Michael. Thank you for your time. We hope to see you in our next class and in our next video. Thanks.